Hi everyone, my name is David Klee, founder of Sequilibrium. Welcome to Module 8 of my course, the SQL Server on VMware Accelerator. We just wrapped up a good overview of the SQL Server virtual machine construction. Now it's time to go through the operating systems that your SQL Server runs on, starting with Microsoft Windows and then moving into Linux. In this module, we're going to cover a lot of seemingly minor things that will all add up to our goals of better stability and performance. We're going to start with covering the VMware Tools package, then hit the power profile, storage practices, network adapters, Active Directory time sync, and then antivirus exclusions. I mentioned it in the last module, but please work with your virtual machine administrators to make sure that your VMware Tools packages are up to date and updated every time they do host level updates. It's very important that they stay up to date because it introduces bug fixes and potentially new features into the operating system. I spent a lot of time in the last module talking about our virtual machine memory pressure and the balloon driver. There is a tremendous amount of misinformation on the internet that talks about disabling the balloon driver. There's unfortunately also pretty clear directions out of VMware.com for how to do so. Please do not disable the driver. It is absolutely imperative that certain virtual machines be able to balloon if the host is ever under memory pressure. The more important thing is to make sure that your critical production virtual machines never get into that state. So instead, use VM-level memory reservations. This will ensure that these virtual machines are never the target for memory reclamation if the host is ever under memory pressure. Next is the Windows power profile. By default, Microsoft wants you to be green. This is quite admirable, and I'm all for contributing to reducing global warming. However, this is not at the expense of your SQL Server performance. You're already going green by virtualizing these servers. Let's make sure that we maintain the performance that we expect. Set the Windows power profile to high performance. By default, it's set to balanced. Now, it might seem redundant to set it here when we recently just set the host performance. I still like to do it here because if this is ever migrated to equipment where your virtual machine administrators miss that setting, this can help maintain performance. Also, by disabling it here, Windows won't even try to park or throttle down CPU cores to save power. If you're interested, you can work with your Active Directory administrator to set high-performance group policies for the Active Directory organizational unit that your SQL servers are members of. This way, you don't have to worry about setting these on each of your servers themselves. If you've ever changed a disk controller assignment for a virtual disk in a virtual environment, you might have noticed that the virtual disk may go offline when you power on the virtual machine after making the change. This is not directly the fault of the hypervisor. This is actually a quirk within the Windows operating system. If a controller is changed, the operational signature for that drive that Windows is monitoring might have changed. Windows has a storage setting built into it that detects a signature change and could knock the disk offline due to this policy. It's a mild annoyance, and you have to go into the disk manager and set the disk online, but it only happens once. We can fix this so you don't have to worry about this. The PowerShell commandlet on the screen shows the virtual storage setting to set the new disk policy to online all. This should be executed on the virtual machine template prior to any of your SQL Server object disks being added to the virtual machine, as this policy only applies to new disks. I spent a lengthy amount of time talking about the para-virtualized SCSI adapter and its performance at the virtual machine layer in the previous module. The default queue depth of this controller is 64. If and only if you're on all-flash, flash hybrid, or NVMe storage, you can check to see if you get a performance gain by changing the queue depths. With the registry setting on the screen for Windows or the KB article below for Linux, you can increase this from a default of 64 all the way up to a value of 254. Please do not blindly change this all the way up to 254. You can encounter situations where you actually get higher latencies in guest because you're pushing much more data to the hypervisor than it can handle. Don't modify this setting unless the underlying storage queue depth components have been reviewed, such as DSNRO and adapter queue depths. If you increase this setting here, but do not tackle the layers underneath, you can increase storage queuing quite considerably. Normally, I find the value of 128 to be a very good balancing act here. Whatever you change this to, or leave it as is, test your changes to confirm that you get a performance gain before you make this change on your production servers. More details about changing this queue depth setting can be found at the KB link on the slide. Microsoft has had the recommendations for decades about formatting the NTFS file system to a 64 kilobyte allocation unit size. In virtual environments, this recommendation does not change. I always recommend that you format your SQL Server object disks to a 64K allocation unit size unless you're on a hyperconverged platform. What I find is that hyperconverged platforms generally don't perform as well for writes with a larger block size. If you're running your SQL servers on hyperconverged storage platforms, test formatting your SQL Server object disks to either a 4 kilobyte or 8 kilobyte allocation size. I normally find that a smaller block size will actually perform a little better for write operations than with a larger block on these platforms. This recommendation is vastly different than what the hyperconverged platform vendors will tell you. I personally have seen my recommendations work better on a number of different hyperconverged platforms in the field, so all you need to do is test it for yourself to confirm which works best for your platform. If you find that a smaller block size works better, don't hesitate to share your results with your VM admin team. They might be surprised. Additionally, larger disk sizes can have a lot of pointer overhead. We can get better performance on these modern storage systems by leveraging the large NTFS file record segment, or FRS, at a 4 kilobyte block size instead of the default 1 kilobyte block. Use the syntax on your screen when you go to format your object disks. Many people ask me about Microsoft's newer file system called REFS. Technically, it is supported underneath SQL Server. However, do a little bit of search engine checks and you'll find that it has a few quirks that may discourage you from using it. It claims to be faster than NTFS, but do your own validation to determine which is better and works faster on your storage subsystem. My personal recommendation is to explore it, as I'm certainly not opposed to progress, but stay away from REFS level compression and/or deduplication technologies when using them with Microsoft SQL Server. It causes a lot of CPU overhead in the operating system, and if you have data reducing storage underneath, you'll find much better results doing these tasks at the SAN itself instead of in guest. By default, Microsoft enables power management features on some network adapters that can allow power savings in the operating system to turn off your network adapter. It's extremely rare to see this cause a problem on production servers, but it's certainly possible, and I've seen it from my own eyes. Just turn this off. You can either go in manually to the Ethernet adapter properties and uncheck that box under power management, or run the PowerShell script on the screen that'll do it for you. I do this as part of my deployment scripts so that I don't have to worry about it ever again. Another change that I endorse is enabling receive-side scaling for the VMXNet 3 network adapter. Receive-side scaling is a technology that allows Windows to use more than one CPU for network traffic handling. By default, it'll only use one, and it usually uses CPU 0. What I find is that for environments with very high network throughput rates, you'll actually run that CPU core up to 100% before you reach peak network throughput. The network adapter is no longer the bottleneck to performance in those cases. Receive-side scaling allows Windows to spread out the workload to multiple CPUs so that you can get much greater network throughput. Your virtual machine network adapter must support this feature, and the VMXNet 3 adapter certainly does. Enable it in the Ethernet adapter properties under Advanced and Receive-side Scaling. It will most likely disconnect and reconnect your network adapter, so do not do this change during production hours. VMware also has a couple of recommended settings for the transmit buffers and the ring sizes specifically for the VMXNet 3 adapter. These are rare situations where the VMXNet 3 network adapter can see a little bit of packet loss under very high loads. As a result, change the two settings highlighted on the screen to ensure that you'll never see this problem. The VMware Knowledge Base article on the screen will give you more details. Part of the reason I spend so much time talking about CPU scheduling and CPU architecture, as well as the virtual machine time sync, is that we have to worry more about time synchronization than we used to in physical machines. Essentially, the longer the virtual machine spends stuck in the hypervisor CPU scheduling queues, there's a fair amount of time that is essentially slowed from the virtual machine. Periodically, Active Directory will come along and resynchronize the guest's time. The virtual machine can actually jump as it resynchronizes. Every time it jumps, if it jumps over a milestone on a task from something like the SQL agent, a job may fail to trigger. That's absolutely horrible. It could also mean that your SQL Server high availability solution can fail. Functions like Kerberos need to be no more than 5 minutes in sync and can result in logins being rejected. Issues like this can cause an availability group for a failover cluster to crash. You don't need that. What I find is that I prefer to increase the frequency at which this server resynchronizes its time with the Active Directory time server. The default value is set to 1 week, which in some high active virtual environments is not fast enough. Take a look at the registry setting on the screen for a setting called Special Poll Interval to set a special polling interval to increase this time frequency. See the link on the screen at Microsoft.com for more details. Another component that we've been doing for decades for both physical and virtual machines has been to set antivirus exclusions for our SQL Server objects. This does not change when it's inside a VM. Antivirus and anti-malware programs and their active scanners can lock SQL Server files and cause slowdowns in the database performance or even stop it from working if the lock is held for too long. You should always exclude files such as data files, log files, backup files, transaction logs, traces, as well as a bunch of different folders and executables in there. Please review the entire list out at the link on the screen and work with your infrastructure team to make sure that all of the exclusions are applied properly to all of your SQL servers. This module was fairly short. We'll now jump over to the Linux operating system, which is fully supported for SQL Server since the 2017 release. Stay tuned.